So you can see behind me, I've gone ahead and set up some stuff. There's one last notion I want to take a look at before we leave conditionals behind, and then kind of end up bringing all this back together in terms of, well, I don't want to spoil it. So what I wanted to take a look at was this sort of combined conditional statement. So you'll notice here we've got our friend P implies Q, and we're linking him up with his converse, Q implies P, hooking them up with a conjunction. So let's take a look at the truth table for this thing. So P implies Q. Yeah, we don't really need to work on that guy. He comes out of our base tables, so hopefully that seems straightforward. We technically worked out the truth table for the converse before, but just to be on the safe side, true implies true. Yeah, remember the order's changed, so this is my left side. True implies true. That part's still true. False implies true. That is a true statement. True implies false. It's false. False implies false. It's true. So there we go. Again, that technically was in the last video, but hey. So now, let's take those two guys and hook them up with a conjunction. Remember, conjunctions are true when both of them are true. That happens right here. Not so much here. Still not here. But then happens again at the bottom. True, false, false, true. So that's a thing. So you may be asking yourself at this point, self, why did Professor Carroll feel like pointing this out? If you kind of trace back here, so you'll notice the cases where we have a true when it's all said and done map back to these two guys right here. Hopefully you notice they match. We've got a pair of trues, gave us a true. So did a pair of false results. If P and Q disagree with each other, we ended up getting a false out of it. That structure is actually particularly important. That's something we refer to as a biconditional statement. So you may have noticed on that base truth table standout, there's a thing that says biconditional. Had a double-headed arrow on it. Yeah, that's what we're talking about when we deal with that guy. So the biconditional really is kind of taking a statement and its converse and saying they both have to be true simultaneously. So P, double-headed arrow, Q. If we were to write this in words, it can be a bit trickier. I'm inclined to say this is more like the way mathematicians talk, and maybe not something that you end up hearing people say on an everyday basis. P, if and only if Q, again, math types like me will sometimes say necessary and sufficient. Don't stress over that. So the idea here is a biconditional statement is true when the components have the same truth value. They don't both have to be true, they just have to match. So that's, a thing. We said the if and only if comes up from time to time. All right, so that's what I wanted to say about conditionals. Now, I promised, if you think way back to when we did this stuff at the beginning of Chapter 1, the goal here, the end game, was to come up with a way to do argument analysis that didn't rely on drawing tons of Venn diagrams. That's actually what all of this is building toward. So in the next section, we're going to revisit argument analysis, and we're not going to have to draw any Venn diagrams. Whether or not writing out lots of truth tables is a gain, I leave for you to decide.